Hey Drew, do you have a minute to listen to my matter presentation? I have to share it in class today, but I want to make sure it sounds accurate first.
Sure, no problem.
Great. Here it goes. Did you know that we are surrounded by matter? Sure we are. Look. The walls, flowers, water, desks, and air in the classroom are all examples of matter. Matter takes up space and has mass. So while the sun is an example of matter, the light that shines into the classroom is not. You and I don't have to share the space we are in. We also can't measure or calculate the mass of light. On the other hand, everything else I mentioned does take up space and have a mass. Some matter is shiny while some is not. Some matter has the ability to rust while some only tarnish. Some matter can float while other matter sinks. Where does all this matter come from? Well, even though we can't see it, matter is composed of these really tiny particles called atoms. Atoms are composed of protons, neutrons, and electrons. Each atom is unique from the other, containing its own special characteristics and properties. The elements that we see on the periodic table are composed of atoms. This means that the element titanium is composed of millions of titanium atoms. This is the same for the other 117 elements on the periodic table. Pretty amazing stuff. Now the elements are organized by atomic number on the periodic table. Elements in the same group share similar properties. Let's take group 17. Chlorine, fluorine, and iodine belong to this group. Each of them is good for killing bacteria. Think about head badger pool, teeth, and wound would be without them. There are three regions of elements: metals, nonmetals, and metalloids. From left to right the elements range from high reactivity to no reactivity. Elements like helium and argon don't care to bond with other elements because their outer shell is stable or full. When we find elements that react with each other, we'll get a chemical reaction. The amount of each substance before the reaction is the same amount after reaction. This is called the law of conservation of matter or mass. Sometimes, just because you can't see what the substance transformed to doesn't mean it no longer exists. Elements are pure substances and so are compounds. You can't break them down and still have the same thing. Mixtures on the other hand are not pure substances, but do come in two forms, homogeneous and heterogeneous. In some cases, like Jell-O, you know what's in it, but you can't see everything that it is composed of. Then there are other mixtures like salads where you can see all the different things that go into it. Before learning about matter, I thought it was going to be really hard to understand because of all the different words and processes. While it was a bit challenging in some cases, I realized that I knew much of this stuff all along, and guess what? So did you. In fact, matter really does matter in our lives. We require it for energy, transportation, and protection. We've known that it comes in different forms and that not all matter works in the same way. We've known that when mixing certain things some reactions are greater than others. Do you remember mixing glue with liquid starch? What about mixing baking soda with vinegar? And let's not forget our attempts to mix oil and water. And so my fellow students, I hope that you have learned so much about matter as I have during this class. Matter is really an amazing thing, and once you understand it you can't help but to want to learn even more.
Wow, Kevin, that's a really good presentation. I learned so much in the few minutes of listening that I think other students will appreciate your summary of what we've been learning. Great job.
Thanks, Drew. I will catch you in second period.
Sure, see you then.